Hello everyone, this is Protesilaos, also known as Prot. In this video I want to show you a script I just wrote that compares the contrast ratio between two colors, the difference in perceived luminance between two colors. So I will switch to my terminal. This is running a Tmax session and I have the script here. I will run some tests, show you what this thing does, and then walk you through the code where I will explain to you my rationale and why I have chosen to implement certain scripting methods, why I decided to use those, to rely on them. So the script is called CLR, which stands for Check Luminance Ratio. It can be also pronounced as color. So CLR accepts two arguments that must be valid colors, which are written in hexadecimal color notation, hexadecimal RGB to be precise. Hexadecimal RGB, maybe you are already familiar with this. You have seen them online if you have done any kind of web development, or maybe you have ever tweaked the colors in your terminal and stuff like that. If you have no idea what it is, I will offer you a primer. Just before I proceed, just to say that the code I will be showing you is an early prototype. I might still clean it up a bit. There are areas that could be improved further, and I also need to add some more inline documentation. But the script already works as intended, and that's why I am demoing it now. Back to the point, what is a valid hex RGB color? So a color consists of red, green and blue channels of light. A valid color can be written can be either 3 or 6 characters long. If it's 3 characters long, the first character corresponds to the red channel, the second character to the green channel, and the third character to the blue channel. So what we call color is in fact an amalgamation, a mixture of 3 separate channels of light, so RGB. So a color that is written, that is 3 characters long, is like this, RGB. If it's 6 characters long, the first pair, so the first 2, are the red channel, the second pair is the green channel, and the third pair corresponds to the blue channel. So with this knowledge, equipped with this knowledge, you already know that this is a valid color. And each character, so each point here, accepts values from 0 to 9 and from A to F. So this is hexadecimal notation. 0 means the least amount, and F means the maximum amount. So in this case, what this means, the 6 zeros here, means 0 of red, 0 of red light, 0 of green light, and 0 of blue light. In other words, this is pure black. And the opposite is full of red light, full of green light, and full of blue light. So pure white compared to pure black. Let's calculate the contrast ratio between the two. 21 to 1. This is the maximum difference in perceived luminance that we can get from this script. Now I will switch to my browser and show you an online tool that I was using hitherto using, but will not be using henceforth now that I have my script. This is webaim.org and it provides a tool called the contrast checker. So I will just run the test here just to make sure that we are doing things properly. So 000 on FFF. This gives us a contrast ratio of 21 to 1. It's exactly what we got here. Now let's come back here and let's transpose the colors. So let's put white first and black next. See if we get any different results. We get the exact same result. This is expected behavior because the script calculates the difference in color, in contrast between the two. It doesn't matter which is the perceived foreground and which one is the perceived background. Same with this tool here in the browser. If I place the white first and the black next, it will still give 21 to 1. Let's run some more tests. Let's check pure red. So pure red is F, so the red channel is full, and the other two channels are empty. It can be written like this, so F00, or like this, FF0000. It's the same thing exactly. And let's compare it to pure white. We get a contrast ratio of 3.99 to 1. Let's go to the browser and see if indeed this is the case. So we have red compared to white. 3.99, correct. So I will not bother you with more demos, especially of the tool that is on the web. I have tested this thoroughly. All the results are correct. Let's clear the screen. CLR accepts two arguments and they must be valid colors. If you pass an invalid color, so for example this is an invalid color because it is shorter than 3 characters, it will throw an error. So this is false. It will tell you that the first color is not a valid color. Transpose these, again it will tell you it's not a valid color. Let's have 4 character long, which again is invalid. It must be either 3 or 6. Now it's valid. So yeah, you can run the tests and see for yourself. And of course you can compare any kind of color. So this is white with near white. If it's white against white, it will be 1. So 1 and 21. That's those are the outer ranges, the outer boundaries of the range. And you can use this tool to calculate the contrast ratio between two colors. Any color will work. And I will explain later why this is a very useful utility and why I specifically need it. I should state at this point that all the calculations that are performed herein are not my own invention. I am just implementing a formula that is provided by the working group, the W3.org working group on accessibility, something like that. Worldwide Consortium, that's the term. The World Wide Web Consortium has a working group on accessibility, and I have a link here in the description to the formula. I will just show it to you right now. So this is the formula here, this part here. Maybe I should increase the size a bit. So I am just implementing this. I am not doing anything else. None of the maths are my own. I am just following along. I am just using this as an excuse to practice my bash, my shell scripting skills, to which we should delve right away. So yeah, let me show you some things that I'm doing. So let's increase the font size a bit. So I am using the built-in method of bash to manipulate parameters. It's called parameter expansion. In a typical scenario, you would, if you want to manipulate the value of a parameter, of a variable, you will take the variable and pass it through an external command like sed or cat and retrieve the output. But for certain operations, you don't need external tools because you can just rely on the built-in functionality of the shell. So in this specific example here, what is here within quotation marks, the way you write parameter expansions is you include within curly braces, within curly brackets, within the braces, you include the name of the parameter, the name of the variable, and then you operate on it. This specific thing here, the column that is prepended to the name of the parameter, means calculate the length of the parameter. So what this thing does here is checks if the length of the parameter is 3 characters long. And if it is 3 characters long, here on the next line, I am also using parameter expansion again. This time, the specific syntax here accepts a length. So this thing, the first number here is the length. The first number is the offset. The second number is the length. This means start counting. Take the parameter and start counting from the beginning. So 0 here means the first character, and then the offset here. So the second number. Count 1, and give me only that, only whatever it is that you are matching. I don't want the rest, so discard the rest. So let me just open a split here. So if, for example, this is the parameter, this is the value of the parameter, what the above will do is it will take f and remove the rest. And I am telling it, do this thing twice. So from here to here, I am telling it, print the first character twice. And we do that in order to convert a 3-color value into its a 3-digit value into its 6-digit equivalent. So this is the equivalent. And we do that for the first character. So we duplicate the first character. Then here we duplicate the second character. We see here from this point here to this point here, we duplicate the second character. So you see the offset now is 1. So we move on to the next character and again count 1. And then same here, the last character, we take that as well. So we take f, we make it ff. We take 0, we make it 0, 0. We take the third 0, the third character, and we duplicate it again. And this gives us the valid color. And all this with Bash. We don't need to use some external tool. Okay, what else do we have here? Maybe we can close this. Let's see here. Okay, yeah, this thing here is the way that you tell the script that all the arguments that are passed to the script. So for each item of all the arguments that are passed to the script, the array. And we run some tests on that. If it's a 3-character long or a 6-character long, we just make sure that we convert the color to 6 characters long. And I will explain now why we do that. Because we want to take each of the RGB channels, each of the red, green, and blue light channels of the color, we want to convert them from hexadecimal notation, so from base 16, we want to convert them to decimal notation, to base 10, because the formula I showed you earlier does the calculations on the premise that we know the base 10 value of each of the RGB channels. So we use again parameter expansion here. It's the same idea. You start from the beginning, you count 2 characters, and this thing corresponds to, the first one corresponds to the red, the second one to the green, the third one to the blue. This notation here, so 0x, informs printf, the command here. It informs it that what you are reading now is base 16, it's hexadecimal. And the D specifiers here stand for decimal. So take the hexadecimal and print it as decimal. So we have printf to do that. We don't need to perform any kind of fancy math. So basically we convert the 2 arguments that we pass to the script, we convert them into RGB, into base 10 color. Just to show you, so for example, this is red written in hexadecimal, and this is the same as red written in decimal. So again, the FF stands for 255, the maximum value of red, the minimum value of green, so 0 of green and 0 of blue. You can find tools online that convert these on the fly if you will, and you can learn more about it. And there are other ways also of defining colors, by the way, but this uses the sRGB space to find the value of a color. So it's a combination of the red, green, and blue channels. Here I have some more bash parameter expansion. So this thing here is performs a pattern match and removes everything that it matches. This starts from the beginning and removes the first match. So this will give me only the decimal value of the red channel. These two will give me the decimal value of the green channel. It has to be 2 because bash parameter expansion is not very powerful, so you cannot do complicated regular expressions and substitutions like you can with the sed, for example. This is a bit more primitive, but because I am trying to hone in on my skills, I am just seeing how far I can go with just parameter expansions. So therefore you have to parse it twice to get just the green decimal value, the decimal value of the green channel, and then the blue channel. You can read online about, or in your terminal if you have the right tools, I'm not sure, info, I think GNU info. But anyhow, you can read about bash parameter expansions in the GNU bash manual. It's very informative, as is the case with practically every piece of GNU software. Documentation is top-notch. It's among the best you will ever get. Because GNU actually cares about users and not just about smartness. So writing code that looks smart but only you can read it. GNU cares about teaching as well. So back to the thing here. The program that performs the calculations, I forgot to say this because it's a dependency for this script, is called calc, and in the Debian archives it is provided by the package apcalc. So I am running Debian Buster and the package is apcalc, but the executable is just calc, and this is a very good calculator. And all math is done by calc. I do nothing myself. I'm just checking if there is basically that's all there is to it. Here again at the very end I am using again this method here to trim the output of the calc command so that I don't get 20 character long number, the floating point. I don't care. 4 characters is enough. We get the contrast ratio. That's all we need. So I will just decrease the font size. That's all there is in terms of the essence of the script. That's all there is to the script. I just walked you through the whole script. It's not a very big script. It doesn't try to do much. It just implements the formula, and as you saw, the only interface you have with it is a single execution of the command, a simple execution with two arguments passed to it. Now maybe I should discuss a bit why would you ever need a script like this? Why would you ever need a utility that compares the contrast ratio between two colors? What's the point? It's because if you ever work with colors, and I assume you are because you are a terminal user, and therefore you might want to tweak the colors of your terminal or some other program you are interfacing with. It's good to know. It's good to have an idea of what color works best against which background, because you want to make things easier on your eyes. If you strive for a certain threshold, you will improve the legibility of the text on the screen. So if you strive for a 4.5, a minimum of 4.5 contrast ratio, you are meeting a certain criterion of accessibility as defined by the working group, the w3.org working group on accessibility. The minimum target is 4.5 contrast ratio, and the higher target, the more ambitious target, the one that is most accessible, is 7:1. The colors that you are looking at right now conform to the highest standard of 7:1, which is also known as WCAG AAA. That's how the standard is formally called. And if you ever open the terminal, the generic terminal that is provided by GNOME or Mate or whatever, and the default color scheme, for example, has many colors that are inaccessible. I think the default color scheme is Tango, I'm not sure. Now I am not blaming the developers or anything, I'm just saying that some colors are difficult to read. For example, they have a very dark shade of blue and on a black background. So let's come here again. So CLR, if you take a dark blue, so for example, this is a dark blue, a very dark blue, and if you put this on a dark background, you get a contrast ratio of 1.33 to 1. That's as if you are trying to read the same color on the foreground against the same background. It's practically indecipherable. Now, I'm not saying these are the exact values, but this means that the color is inaccessible. And to me, inaccessible colors is a sign of bad design, of a design that has not been implemented thoroughly enough. I think accessibility is, of course, of paramount importance in order to be inclusive. We want to make our code, our interfaces useful to every user out there. We don't want to discriminate against anyone. But I think accessibility is benign, has a benign effect on everyone, because it makes text on the screen more legible and therefore reduces the strain on your eyes. So you can code for longer or read for longer or just look at the screen for longer without experiencing, even subconsciously, any kind of pain. And I am just discussing all of this. I am familiar with these concepts because I have developed lots of themes, lots of color schemes. I have worked, I have a bit of experience on the matter. And my latest project in this front is a set of themes called Tempus themes. This is a set of color schemes that conform with the accessibility standards that I mentioned earlier. And here I am running my custom desktop session on Debian, which is its centerpiece is the binary space partitioning window manager. And I have showed this in other videos as well, where I have a script that brings up the D menu interface, and it allows me to switch themes. So I can switch to another item in the Tempus themes collection. The one I am using now, it's the Tempus Night, and this one is a very accessible color scheme. And I can use this to switch either to a light theme or to another dark theme that has a lower threshold, a lower contrast ratio between foreground and background colors. So I will do just that for the purposes of this demo. Let's switch to another dark theme that has a lower contrast ratio, still accessible but lower. Summer, Tempus Summer. Let's switch to that. Okay, my Vim here has switched colors, my terminal as well. If I spawn new terminals, the bar at the top switched as well. Basically the whole thing. This is an operation that performs a live theme change throughout all my applications. And I'll just switch to a light one as well. Actually no, I have other scripts on that. You can check my backlog. The point is that it's good to know the contrast ratio between two colors, because you can make more informed decisions about the choice of color. And this script, which, as I said earlier, it's just a prototype, and I may be iterating on it further because I think there are areas that could be improved a bit. This script is distributed with my dot files. And my dot files are available on gitlab.com/protesilos/dot files. And of course, it's not just this script, it's everything that is part of my custom desktop session here on Debian Buster, also known as Debian 10, which is the upcoming release of the distro. That's all for now, folks. Thank you very much for your attention, and sorry for rambling a bit at the end. Goodbye.